Okay, so welcome back to the Unity Lab, this time for the 7th week. Yeah, for today we will try to simulate the law of conservation of momentum. Yeah, in which case we will try to simulate the collision of two objects. We will use our previous Hello Physics Unity project, so make sure you have finished the one from week 5 and week 6. Yeah, okay. I have my Unity open here. So I will just duplicate my friction scene here. Yeah, press Ctrl D, and then let's rename it collision. Press F2, collision. Yeah, please don't mind these icons because I have turned on my Unity Collab. Yeah, just ignore any of these icons for now. Okay. Okay, so I have renamed my scene to collision. Let's open it. Yeah, and then please download Pol A and Pol B from Classroom. I have downloaded over here. Let's see. Yeah, Pol A and Pol B as well. Please download both of them from Classroom and then import it to your sprites folder as usual. Yeah, and at the hierarchy, let's delete our car and add Pol A and Pol B. Oh, sorry. Please don't select both of them. Yeah, just add them by one. Yeah. If not, then you will be greeted with a new animation window. Yeah. We don't actually want to create any animation, so just add both of them manually. Yeah. Let's say I add my Pol A first. Yeah, and then I will give reposition it to a position like, let's say, x equals to -7, and then y is not 0. I think negative. Oh, sorry, not 2. Not -2, but yeah, I guess 2 will be fine. Yeah, and then I will add my pole B. I will position it to x equals, let's say, 7, and y to 2 as well. Yeah, it's up to you for the x positions of both poles, but make sure both of them has the y position the same. Yeah. So for example, my pole A is in y equals to 2. Make sure that your pole B also is in y equals to 2 as well. Okay, we have added pole A and pole B. Now let's modify the UI, yeah, to look something like this. Yeah, initial V1 for the pole A, initial V2 for pole B, the mass 1 for pole A, mass 2 for pole B, and then we have current V1 and current V2 in meter per square. Sorry, not meter per square, meter per second. And also we need the coefficient of restitution here, or E, yeah, for short. So we will only need to add one new text and input field. Okay, I will expand my canvas first, and I will focus to my canvas for now. And then let's see, for the current velocity text and acceleration text, yeah, I will move it upwards to maybe, let's say here. Yeah, I think here is fine. And then for now, I will duplicate the kinetic coefficient, both text and input field here. I will duplicate it and I will move it right over here. Yeah, and now let's rename everything. Yeah, this one is initial V1. Yeah, let's see. Yeah, it's initial V1 in meter per square. Oops, sorry. Initial V1 in meter per second. And then this one is, let's say, pole A mass in kilogram. For this text mp2, it's actually velocity. Let's say it's current v1, yeah. Current v1 in meter per second. This one is okay. Acceleration, let's change it to current v2, also in meter per second. This one is no longer static coefficient, but it is initial v2 in meter per second. This one is kinetic coefficient, ball P mass in kilogram, and then this one should be kinetic coefficient, yeah. Coefficient of restitution. Oh, sorry, restitution. Okay, and then I will rename all my input fields, yeah. Let's see here. Velocity 1 input, okay. Let's follow the slide naming. Velocity 1 input. So this one should be, let's see, mass 1 input. Okay, mass 1 input. Okay, and then this one should be current velocity 1. Yeah, I will name it current velocity 1 text. This one is current velocity 2 text. This one should be velocity 2 input, and then this one is mass 2 input, and last one, this one is coefficient of restitution text. Yeah, coefficient of restitution input. Okay, I think that's all. Yeah, for the user interface. Okay, let's continue to modify our balls then. Yeah, we have ball A and ball B. Let's add rigid body to both balls. Yeah, you can safely select all of them. Yeah, and then add component. Let's add a rigid body 2D. Yeah, this one. And please turn off the gravity. Yeah, set the gravity scale to 0. Okay, the next thing we need to do is to add a circle collider 2D. This one, circle collider 2D. Yeah, we haven't met with this component yet. Yeah, what is exactly a circle collider 2D? Yeah, this component actually tells Unity where the borders for the setGame object are. Yeah, we will need this circle collider 2D when we want to know whether the object hits or collides with something or not. Yeah, hence the name collider. We have many other form of collider. Yeah, if you search for collider, yeah, we have box collider 2D, we have capsule collider 2D, composite, and then polygon, edge, tile map, and so on. Yeah, as well as the not 2D part. Yeah, actually the collider with no 2D in its name, yeah, is used for 3D games. Yeah, so please remember, if you are creating 2D games, you must use the components that end with 2D in its names. Yeah. Okay, and then for the size of the colliders, yeah, will automatically fits the game object. Yeah, although if you want, you can always edit the collider. Yeah, so for example, if you want to edit the collider, just click this button. Yeah, and then you can resize it as you wish. Yeah, so I think this ball is not really a circle. Yeah. Okay, that's fine. Yeah, I will cancel my colliders editing then. Yeah, hopefully. Oh, okay. I can just simply reset my circle collider duty. Okay. And make sure that my undo does not also undo the gravity scale. Okay. They are both still 0 here. Okay, so I think that's all for the ball A and ball B components. Yeah, we have added the rigid body and then added also the collider 2D. Okay, for the script now, let's duplicate our car RP scripts. Car RP, where are you? Okay, this one. Duplicate, rename it to ball, and also rename it in the Visual Studio. Yeah, I will open my Visual Studio first, and then I will need to edit my car RP's name, class name. Yeah, currently it is still car RP. We should edit this class name into ball. Okay, I will wait my Visual Studio to be ready first. Yeah, I think it's ready for now. Let's rename it ball with a capital P. Yeah, make sure you edit the class name to be the very same as your file name. Okay, I think my script is now correct. Yeah, at least for the class name. And then we will need to add these new fields. Yeah, TMP input field. We have in speed input already, I think. Yeah, we have the speed input. And then let's see, we need the mass input and E input. Okay, let's add them. Mass input and then E input. Or if you want, you can always name it coefficient of restitution input. Yeah, if you afraid you will forget what E is, yeah, just rename it with coefficient of restitution. Yeah, although this name is now quite long compared if you name it E input. Yeah, but it's up to you. Okay, and then we have public TMP text for the current fee text, public TMP text, current velocity text, and we have rigid body here. Yeah, private rigid body RP and RP2. Yeah, for RP2, we will store the rigid body from the second pole. Yeah, if this is pole A, then RP2 will contain the rigid body from pole B. Yeah, if this is pole B, then we will store the rigid body from pole A. Okay, and then we have the float init speed. Yeah, private float. Let's rename speed into init speed here. Initial speed. Yeah, and then you must rename all of speed into initial speed. Yeah, let's see if I can rename this field. Okay, apply rename refactoring. Oh, okay. Yeah, so my speed field is now initial speed. Okay, and then we have E also. I will just leave it to E. And then let's see. Okay, everything is complete for the fields. Yeah, speed input and mass input is for the respective poles inputs, and E input for the coefficient of restitution. RP2 to enable the use of the other pole's rigid body. Yeah, and in the speed, just replace the old speed field. Okay. Okay, for the start is still the same. Yeah, but remember to replace your speed into initial speed. Yeah, if you apply the initial uh, speed refactoring, then you will be fine. Yeah, but if not this, please rename it, yeah, manually. Okay, and then for the void update, we will need to display our current velocity text. Okay, so let's add it. Yeah, previously we have deleted the update method, so just add it again. Yeah, update. Okay, and then let's just type it. Current velocity text is rb.velocity.toString. Yeah, and here it is formatted as f2. Okay, for the set speed, the changes are, let's see, initial speed is still float.parse, speed input dot text. Yeah, it's still the same, speed input. Yeah, if you want, you can also change it to initial speed input, yeah, or initial velocity input. Yeah, but I will leave it still speed input. Okay, and then rp.velocity equals to vector2.rad times initial speed. Okay, and we need to add these two lines, yeah, rp.mass. We will set the rigid bodies mass, yeah, rp.mass equals to float.parse from the mass input dot text, as well as we need to initialize e with float.parse from the e input, yeah, or here I rename it to coefficient of restitution input. Okay, yeah, I think that's all. Now we are introduced to a new Unity message, yeah, that is on collision enter 2D. Yeah, before we type all of this, I will explain it first. Yeah, what is a on collision enter 2D? Yeah, on collision enter 2D is actually a Unity method, yeah, or a Unity message that will be run when the object that has the script attached to it, yeah, collides with another collider. Yeah, this is why we need to attach a circle collider 2D, yeah, in our previous steps. Okay, when the collision happens, yeah, at the very first frame when both collider collides, yeah, then on collision enter 2D will be raised, yeah, and then we can do something within this method. Yeah, when the collision happens, we will calculate the current ball news velocity. Yeah, and this process will also happen to the other ball as well. Yeah, our job now is to calculate the ball's new velocity. Yeah, how to actually calculate the ball's new velocity? Yeah, you must use the law of conservation of momentum. Yeah, the initial momentum equals to the final momentum. Yeah, m1v1 plus m2v2 equals to m1v1 quote plus m2v2 quote. Yeah, and you also need the coefficient of restitution formula here. Yeah, E equals to negative v1 quote minus v2 quote, yeah, divided by v1 minus v2. Yeah, these are the formulas needed to determine the ball's new velocity. Yeah, you can derive it by yourself, or I have actually derived it here. Yeah, please pardon that I used Indonesian here. Yeah, actually they are both the same. Yeah, HKM is LCM, law of conservation of momentum. Yeah, let's just use m1v1 plus m2v2 equals to m1v1 quote plus m2v2 quote. Yeah, and then the initial momentum. Yeah, we can summarize this as initial momentum. Yeah, initial momentum like this. Okay, and I replace the v1 quote by doing manipulations with the E formula. Yeah, E equals to negative v1 quote minus v2 quote divided by v1 minus v2. Yeah, I will bring the denominator to the left side of the equation. Yeah, so E times V1 minus V2 equals to negative V1 quote minus V2 quote. Yeah, I just multiply it by negative 1 so that the negative sign is moved also to the left side. Yeah, negative E times V1 minus V2 equals to V1 quote minus V2 quote. Yeah, and I will calculate V1 quote is actually V2 quote minus E times V1 negative V2. Yeah, and I will summarize this. Let's see. Yeah, I will summarize the E times V1 to V1 negative V2. Yeah, sorry. I mean, I will summarize this term E times V1 minus V2 into E. Yeah, so we simplify the equation. Yeah, if you have not simplified the equation, then you will be greeted with something like this. Yeah, it's very ugly. Yeah, I have tried this myself before, and I stuck at this equation. Yeah, it's very ugly. Yeah, but if you summarize some known equations, yeah, for example here, we summarize it as initial P, and then this part we summarize it to E, uppercase E. Yeah, and then we can simply change this V1 code to V2 minus E. Yeah, so here the initial P equals to M1 V2. So let's see. Oh, this line. Yeah, let's continue from this line. Yeah, the initial P equals to M1. Let's replace the V1 code with V2 code negative V2 code minus E. Yeah, everything else is still the same. And then let's multiply this M1 to both variables. Yeah, M1 V2 quote minus M1E plus M2 V2 quote. Yeah, and then M1E, I will move it to the left side. Yeah, so that I can simplify the right hand side. Yeah, the initial P plus M1E equals to V2 quotes time M1 plus M2. So I will get V2 quote equals to initial P, yeah, the initial momentum plus M1 times E divided by the sum of both masses. Yeah, and then we have V1 quote is still V2 quote minus E, where E equals to the coefficient of restitution, yeah, small e times V1 minus V2. Yeah, that's why you will get something like this. Yeah, V2 quote equals to the initial momentum plus M1 times E times V1 minus V2. Yeah, all divided by M1 plus M2. And you have V1 quote equals to V2 quote minus E times V1 minus V2. Okay, so the summary of what the code will do, yeah, we get the rigid body first and the ball script component to the other ball because we need to access the speed of the second ball, yeah, as well as the second ball's mass as well. We calculate the momentum m1 v1 plus m2 v2, and then we calculate the other ball's new velocity using this, yeah, v2 quad equals to blah blah blah, and we also calculate the current ball's new velocity from this formula, and then we will apply it to the rigid body. Okay, I hope everything clears out from this explanation. Yeah, and then we will be able to write down these codes. Yeah, okay, let's do that. Let's add a Unity message here on collision enter 2D. Yeah, okay. And then we can write down our code now, yeah. Get the other ball, rigid body, rigid body, rigid body. Yeah, RB2 equals to collision dot rigid body. Yeah, and then we get the ball script or component here, yeah, component from the others ball. Yeah, so usually sometimes, not sometimes, but usually I will change this parameter, yeah, not collision, but usually I name it other. Yeah, so I remember other is the other collider that collides with my rigid body or my collider. Yeah, but this is compulsory. Yeah, you don't really need to change the parameter name into other. Yeah, you can simply leave it to collision. Yeah, that's fine. Okay, get the ball script. Let's store it to ball2 equals to other dot game object dot get component ball. Yeah, and then let's get the mass and speed. Get other balls mass and speed float mass2 equals to ball2 dot mass. Wait. Oh, sorry, not ball2, but from RB2. RB2 dot RB, not PR. RB2 dot mass as well as float initial speed 2 equals to ball2 dot initial speed. Yeah, here it's simply called speed 2, that's fine, yeah. And then let's calculate init momentum. Float initial momentum equals to, yeah, this one is M1 V1 plus M2 V2. Yeah, M1 you can get it from the current rigid body's mass. Yeah, M1 times V1 initial speed plus M2 you have mass 2 and then multiply it by where is it? Yeah, oh, initial speed 2. Initial speed 2. Yeah, so we calculate the initial momentum first. Why? Because we need to use it, let's see, over here for the V2 final. Yeah, or V2 quote here. Okay, and to simplify everything, I will create a new variable, yeah, for the E times V1 minus V2. Yeah, this one is optional, yeah, you don't really need to do this. Optional, calculate, I will just name it big E, yeah, or the uppercase E. Oh, where is it? Okay, calculate E. Float E equals to the E times velocity, initial velocity 1 minus initial velocity 2. Yeah, or initial speed in this case. Initial speed minus initial speed 2. Okay, and then we can calculate the V2 final. Calculate the new speed for other ball. Yeah, float V2 final equals to Okay, let's see. Yeah, here the equation is quite ugly. Yeah, I will use this equation instead. Yeah, the initial momentum plus m1 times e divided by m1 plus m2. Okay, let's say initial momentum plus rp dot mass times e divided by rp dot mass plus mass 2. Yeah, and then we can also calculate the V1 final. Yeah, because we need to calculate for the new velocity for ourselves. Yeah, for the balls itself. Calculate the new speed for this ball. Float V2 final. No, sorry, not V2 final, V1 final. V1 final is V2 final minus capital E. Yeah, the big E. Okay, then we can simply apply it. Apply to rigid body. Rp dot velocity equals to vector 2 dot right times V1 final. Phew, okay, we are done for our on collision enter 2D script, yeah. Save it. Yeah, and then for the final preparation, yeah, we can go back to Unity and attach everything as usual. Yeah, but this time we will need to attach the ball script to both ball A and ball B. Okay, I will attach to ball A and ball B. Yeah, now you need to be careful with the fields. Yeah, for ball A, the speed input is from velocity 1. Mass input is from mass 1 input. Coefficient of restitution is actually both the same, yeah, from the coefficient of restitution here. And for current velocity text, it's current velocity 1 text. Yeah, but for ball B, yeah, the speed input should be velocity 2 input. The mass input should be mass 2 input. Coefficient of restitution is still the same, coefficient of restitution input or E input, yeah. And then for the current velocity text, it's current velocity 2 text. Okay, so the initialization of fields from both balls are complete. Yeah, the last part for the button, yeah, for the on-click listener, now we need to do this twice. Yeah, make the button access both balls at once on the on-click menu. We can do it by pressing the plus button once more. Yeah, here we have already one listener, although it's missing from now. Yeah, please click plus button one more time. Yeah, and then assign ball 2 and ball B. Yeah, for both listeners, let's select the ball set speed method. Okay, ball set speed method. And I think we are done. Yeah, let's test it with various test cases. Yeah, let's use with something we have done on the earlier exercises. Yeah, we have the initial V1 5, initial V2 minus 7, M1 is 2, M2 is 1. The E is 0.5. I think this is from the third exercise. Yeah, let's see. Third one. Okay, this one. Yeah, M1 is 2, V1 is 5. Let's just test this out. Yeah, don't forget to save your scene. Okay, I will zoom out a little bit. Right here, initial velocity v1 is 5. Oops, sorry, 5. And then initial v2 is negative 7. Yeah, pole A mass is 2. Pole B mass is, where is it? Yeah, oh, this one, 1. And then the coefficient of restitution is 0 0.5. 0 0.5. Okay, hopefully we have the correct result here. Current velocity when they are colliding is actually negative 1 and 5. Okay, start. Yeah, we have the current V1 is now negative 1. Yeah, the same, yeah. V1 quote here is negative 1 and the current V2 is 5. Conforms with this, yeah. V2 final is actually 5 meter per second. Yeah, so we know that our simulation is correct. Okay, what about the coefficient of restitution equals to 1? Let's try it out. Yeah, we have the initial V1, let's say 5. And I will give the initial V2 of negative 5. Yeah, and regardless of the mass, let's say pole mass A is 1, pole mass B also 1, coefficient restitution is 1. Yeah, if everything is correct, yeah, the current velocity will just reverse themselves. Okay, nice. Yeah, once more. This time with the coefficient of restitution is 0. Yeah, if I give the initial velocity for the first ball is 10 and the second one is negative 5 with the same ball mass and the coefficient of restitution is 0, yeah, I think both of them will move to the right. Yeah, let's see. Okay. Yeah, what about if we have the initial velocity is the same? Yeah, V1 is 10, V2 is negative 10. Both balls have the same mass, but the coefficient of restitution is 0. Okay, my guess is they will stop. Let's see. Start. Okay, both of them stops. Yeah, with the current V1 is 0 and current V2 is also 0. Okay, so our simulation is complete and correct. Okay, let's continue. Yeah, everything is correct for now. Yeah, if you have any difficulties, any errors, please don't hesitate to ask me, yeah, in the Hangouts group chat, or you can also comment below. Okay, the third part of our class today, yeah. Actually, this is the second part of the Unity Lab session. Yeah, but this one is actually homework for you. Yeah, please use Unity to make a new scene that simulates the bouncing ball. Yeah, the input will be the ball starting height, h1 in this case, yeah, and the ball's coefficient of restitution, E. Yeah, the output will be the ball's second peak height, yeah, h2, and you must also create the bouncing animation as well, okay? Yeah, please zip it and turn into the classroom with the usual format at the stipulated deadline. Okay, if you have something you need to ask, yeah, maybe for this homework, yeah, you need to ask something, yeah, just ask it, okay, in the Hangouts group chat as usual. Yeah, so I think that's all for today. Yeah, thanks for joining me. We will meet again at the 8th week, yeah, because for the next 2 weeks you will have the exams. Yeah, so we don't have any classes. Yeah, we will meet again at the 8th week next 2 weeks. Okay, I'll see you again.